In this video, we're going to talk about what makes two ratios proportional and how to check and see if a pair of ratios forms a proportion. So first, let's do that definition. Two ratios are proportional. They are in proportion with each other if they are equivalent. That's our main idea today, and that's what we're going to be using to answer the following questions. Let me talk about that idea for a little bit more before we get into question 1. If I have a square and I take 2/4 of it, or I have a square and I take 4/8 of it. Either way, I have taken up 1/2 of the original square. 1/2 is the same as 2/4 and is the same as 4/8. Those are all equivalent ratios, which means that those ratios are in proportion to each other. They form a proportion. So today we'll be given two fractions and we'll want to check and see if they are equivalent or not. Our first example says 4/2, 4/2, and 20/6. There are two different methods, and I'm going to do both of them in this case to see if these ratios form a proportion. You wouldn't normally do both methods unless you were asked to check your work. I'm going to do both methods here in order to introduce both of them to you. The first method we can do is to put each ratio, each fraction, into its most simplified form. For example, 4/2 is really 2/1, or just 2. Okay, 4/2, 4 divided by 2 is 2. So let's check the other one. 20/6 is another way of saying 10/3, and this can no longer be simplified because 10 and 3 do not have any common factors. Well, is 2 equal to 10/3? Are 2 and 10/3 equal to each other? Well, no, they aren't. Okay, so this is a no. Here is another way that we could check. We could take 4/2 and 20/6 and say, I wonder if these are equal. And we'll put a question mark on that equal sign. Well, whenever we have things in the denominator, we want to clear them and see if things work out. So we're going to multiply by 6 on both sides to clear the 6 on the right. So we'll get 6 times 4/2, well, 24/2 then, equals 20. And we want to clear this denominator too on the left. 24 equals 40. Well, is that true? No, of course that's not true. So another way is to multiply by the denominators on both sides and see if it comes out to a true equation. A faster way of doing that multiplication by denominators is cross multiplication. So 4/2 and 20/6. Well, 4 times 6 is 24, and 20 times 2 is 40. Look that those are the same numbers that we got right up here by clearing denominators. Well, 40 is not equal to 24, so 4/2 is not equal to 20/6. No, these do not form a proportion. Let's check the ratios on number 2 and see if they are proportional. 3/2 cannot be more simplified because 2 and 3 only have the number 1 in common as factors. But 18/8, they both have the number 2 in common as a factor, so 18/8 can be written as 9/4, so that's equal to 9/4. 3/2 and 9/4. Well, 9/4 is the most simplified we can get of this because 9 and 4's only common factor is 1. So 3/2 is not equal to 9/4, which means it's not equal to 18/8. So no, these are also not proportional. In number 3, we have 4/3 and 16/12. 4 and 3 don't have any common factors besides 1, so 4/3 is as simplified as it gets. And then 16/12. Well, they are both divisible by 2, so I'll start with that. Divide them each by 2. And I get 8/6. Well, those are again both divisible by 2, which means I get 4/3. Hey, look at that. 4/3 and 4/3, those are equal to each other. So yes, these form a proportion. And for those of you shouting at your screens right now, yes, I could have noticed that 16 and 12 were both divisible by 4. Okay, but if you don't notice some of those higher numbers right away, I want you to understand that it's also possible to go step by step. Whatever factor you notice that they're both divisible by, you can use and then keep going. You can do it in more than one step. We found one pair to be proportional, so let's see if our luck holds here. 4/3 and 8/6. Well, let's use that cross multiplication method we were looking at earlier. So 4 times 6 is 24, and 8 times 3 is also 24. So since 24 equals 24, 4/3 equals 8/6. Okay? 4/3 is just a simplified version of 8/6. Okay, you would multiply the numerator by 2 and the denominator by 2 to get 8/6 if you were working from 4/3. So yes, we found another pair that were proportional. Now how about 12/24 and 3/4? Let's check into this. Well, 12/24, those are both divisible by 12 actually. So 12 divided by 12 is 1. 24 divided by 12 is 2. So we're still comparing that now to 3/4. Well, I know that since 1/2 is half and 3/4 is more than half, that these cannot possibly be equal to each other. They cannot be equivalent. So no, we've broken our winning streak of ratios that are proportional. This pair is not proportional because the simplified versions of their fractions are not equivalent. Last but not least, we'll go to number 6. 6/9 and 2/3. 6/9, those are both divisible by 3. So we get 6 divided by 3 is 2, and 9 divided by 3 is 3. Aha! Right away, 2/3 and 2/3. Let's remember again that cross multiplication method should get us the same answer. 6 times 3 is 18. 9 times 2, also 18. So this works out. Yes, we have another pair of proportional ratios.